In this video, we're going to do an introduction to complex numbers, also called imaginary numbers. So before we do, I just wanted to give you kind of an overview of the number system so you see where these fit in. So when you first learn numbers, you learn numbers like 1, 2, 3, 4, 100, and so on, and also maybe throw 0 in there. These are called the whole numbers. If you don't include 0, they're called the natural numbers, sometimes called the counting numbers. It's just all the positive integers. So these are whole numbers. And then at some point you learn negatives as well. So you've got -1, -2, -100, -53. All the negatives plus the positive whole numbers make up the integers. But all of these don't include decimals and fractions and that kind of thing. So if you start including decimals and fractions, things like 4/3 or 0.52 or 7.3 repeating, any of these can be written as fractions. And so these are called the rational numbers, because they're ratios. They can be written as fractions. It includes decimals that end or repeat. However, if you ever have a decimal that doesn't end or doesn't repeat, like pi, that's what we call irrational numbers. So that would be like pi and the square root of 2 and like 0.18463, I don't know, just a decimal that goes on forever without repeating or ending. All of those are irrational numbers. Those are kind of in their own box. So the rational numbers includes the integers, and the integers includes the whole numbers. Irrational numbers are their own thing. It's just any decimal that goes on forever, and they can be negative too, but any decimal that goes on forever without repeating. So all of this together makes up what we call the real number system. These are real numbers. Anytime you say the domain is all real numbers, you're saying it could be any of these things. So far, these are all the numbers that you have learned. However, what is a non-real number? And so that's what we're going to get into today. So it's its own thing. Let's just make a box over here. It's its own thing. It's not a real number. So this is the real numbers. And they're called imaginary numbers. It's not a very good name because they're not imaginary, they do exist. It was poorly named, but we'll get into that. So what does that even look like? What does an imaginary number look like? Oh, and by the way, if you combine imaginary numbers with real numbers, that's what's called a complex number. So all of this combined is the complex number system. A complex number could be a real number, it could be an imaginary number, it could be those combined. So when you hear complex numbers and imaginary numbers, they're used interchangeably a lot. Okay, so here's where imaginary numbers come from. First of all, think back to the quadratics unit. If we graph x squared minus 1, we bump down 1, and then we draw our regular x squared graph. Notice that this has two solutions. Remember, the solutions to any equation are where it hits the x-axis. Those are its roots, its solutions. So this one has 2. In fact, all quadratics actually have 2 solutions. However, look what happens with this one. This one gets bumped up 1. So its vertex is here. This one doesn't hit the x-axis. So in the past, we've just said, oh, it has no real solutions. The key being real solutions. It has no real solutions. It still has 2 solutions though, they're just imaginary. So like, where are the solutions? You could actually draw a third axis that's like imaginary numbers, and it would hit the x-axis in that third dimension, but we're not gonna get into that. So basically, here's where imaginary numbers come from. Let me see here. So let's go back to the x squared plus 1, and we're trying to solve it. We're trying to see where it hits 0. if I solve this, I subtract 1 from both sides, and so I get x squared equals -1, and then I square root, and I do plus and minus, but the problem is I can't square root a negative. And so at some point, mathematicians decided, well, what if we could? Let's just say that we can square root a negative. What are we going to call it? And they called it I. So the square root of -1, we call that the imaginary unit, I. Usually I draw a little hook on the end so it doesn't look like a 1, but it's called I. That's all imaginary numbers are. They're just square roots of negatives. By the way, like, some people think this is dumb. Like, why can't we just decide something exists because we want it to? But I will say, like, back in the day, way back in the day, people didn't think that negative numbers would be useful. They were like, if I have 2 apples and take 3 away, I mean, that can't happen, so why do we need negative numbers? And clearly we need negative numbers. Same thing has been true with imaginary numbers. It might seem like, why do we need those? But they're used in animation, electricity, circuits. If you're going to be an electrical engineer one day, physics stuff like heat flow and fluid flow, launching a satellite, all of these things actually involve imaginary numbers. So they are useful. Also, maybe one day you'll invent the next math thing that seems useless but ends up being needed. So it's exciting. Again, so imaginary numbers are the square root of a negative. In particular, I represents the square root of -1. Let me just be clear. When you square root 9, you get 3. When you square root -9, it feels like, well, shouldn't I just get -3? That's actually not the case. The square root of 9 is actually +3 and -3, because if I do 3 squared, I get 9, and if I do -3 squared, I get +9. There's no way I could take some 3's and multiply the same 2 3's together and get -9. So this is imaginary. Before it didn't exist. Now we can split it up using our radical rules. So we know that the square root of 9 is really like the square root of -1 times 9, which is the square root of -1 times the square root of 9, which the square root of 9 is just 3. And the square root of -1, as we've already discussed, is I. So the answer is I times 3, or 3I. That was a really kind of long way of writing this out. Basically, just square root the 9, it's 3, and if there's a negative in there, just put an I on the end. All right, for example, square root of -25 would be 5, but I because it's negative. Or the square root of -4 would be 2I, and so on. Technically, I is a radical, so all the radical rules still apply. Let me see here. No, we'll get to that in a second. So, for example, if I do 2 root of 5 plus 3 root of 5, going back to non-imaginary stuff, the real numbers, how would I add these up? Well, I would just do 2 of these plus 3 of these makes 5 of them. Just combine like terms. Same thing applies with i's, so if I had like 2i plus 3i, it's just 5i. Again, just combine like terms, almost as if it were an x. Just to be clear, this is basically 2 times the square root of -1 plus 3 times the square root of -1 equals 5 times the square root of -1. You can do subtraction as well, so 8i minus 5i would be 3i. Again, just combining like terms with i's. So in the next video, we'll get to adding and subtracting and multiplying.